Hello, folks. Welcome to part 22 of Learning Rust. This is part of my Learning Rust series and as part of the 100 Days of Rust, and I am on day 11 today. So the last exercise we were looking at was like primitive types 4. It was around slices, and there were some hints around what you can read. So I went ahead and read about like say what is ownership, references in borrowing. It was pretty interesting, and slice type. Mainly slices being the thing that they were asking me to read, but I wanted to read this to understand that. There was also this coercion thing that I haven't looked into. Um, okay, one moment. Interesting. So this is the book. This is Nomicon. I don't know what's a Nomicon. Introduction. The rest Nomicon warning. This book is incomplete, documenting everything and rewriting outdated thoughts take a while. Okay, so this is like some new thing, I guess. Uh, let's just say Nomicon. Then you come here, okay, and you see coercions, okay. So it's the stable thing. I mean, this is still incomplete though. It's another book, I guess. So types can implicitly be coerced. Okay, so this is pretty short. I'm going to read it as part of this itself. Um, Types can implicitly be coerced to change in certain contexts. Okay, these changes are generally just weakening of types. Okay. Largely focus around pointers and lifetimes. Okay. They mostly exist to make Rust just work in more cases and largely harmless. For an exhaustive list of all type questions, see the question types. Okay. Section on the reference. Okay. We are looking at only this rate questions. Yeah. Note that we do not perform questions when matching traits. So question types isn't reference. Okay. Let's just take an overlook of this question type. Following types, derivatives, subtype. Okay, interesting. What kind of coercion or change is possible? Okay, so do not perform any coercion when matching traits except for receivers. Okay, there's an implementation. Okay, this I have no idea what traits and like I think it's like an interface and an implementation and whatnot. There's an implementation like impl for some type U and T causes to U that does not constitute an implementation for T. Okay, that's a bit complicated. I'll probably come back to this later. Will not type check even though it is okay to coerce T to T and there is an implementation for it. I'm not sure about this. I'll probably come back to this later. Just to ensure that I will probably come back to this later, I'm just going to check if this is even there as a thing. Primitive types, vectors, move semantics. I think move semantics is about moving and ownership, basically moving the ownership and all that. So I'm guessing it'll be there. Clippy. Okay. If it's not, well, we'll figure it out. Cool. So yeah, coercions is something that I'm gonna look at probably later when I try to understand these and like understand implementation traits and whatnot, and then like be like, okay, so this is what it means. So yeah. So now I'm gonna go ahead and like try out the next exercise. By the way, before that, to understand this better, this is basically like this is borrowing. Every reference, this is a reference, and every reference is called borrowing. So you're borrowing, and this is an immutable reference. You can't mutate this, and you're borrowing the value like the index 1 to 3 inclusive of 3. So that is 0, 1, 2, 3. So 1, 2, 3, 2, 3, 4. And yeah, so you're pointing to this same data, but you're only borrowing it. You don't have ownership of it. This has the ownership of it, and when it goes out of scope, it's removed and all that. The other way to do something like this is like have data like have two integers which point to the different indexes, but the problem with that is that would be disconnected from the array itself. For example, the array could change, but the two integers that you have, say 1 and 3, would just remain, and it would have no meaning if say this array was like emptied. So that's what they talk about in the book. One moment. So read the book, do the lessons course. Okay, this is the course that you're trying. Anyways, grow with trust. Okay. So read the book, go to the book. Here you can see the understanding ownership. You can check out this references in borrowing, which will tell you about why it's not a great idea to actually use indexes to refer to parts of a collection or like something like string or array of integers and whatnot, right? So you can go check it out, how Rust can help you ensure that you don't have much problems, especially logical problems that get that are not caught at compile time. And let's say you didn't have tests also. Ideally, you should have tests, enough tests to check out everything, but compile time errors also help a lot, right? So with that, let's move on to the next exercise. I'll remove I'm not done, and I'll put this Rusling's watch. And let's see what's the next exercise we have. Okay, so yep, 2, 3, 4. Okay, so we are in the primitive types 5, and exercises. Your pattern here, cat. Okay, that's good. Expected pattern. Okay, there's no error code. Cool. So we gotta look at this thing. So this file, line 9, column 33. So cat. So it's, yeah, I don't know. This is like a tuple, I think. So it's a tuple with a string literal, and string literals are actually string slices or slices of strings. So you can see that over here. You can see that over here, string literals are slices. String slices are slices of strings. I don't know what's the notion there, but anyways, string literals are slices. That's why, and slice is represented by this ampersand and slice of strings, ampersand of string. And this is a float 64-bit. Okay, so this is a tuple. Okay, so destructure the cat tuple. Okay, so that the print line will work. Okay, name and age. Okay, so can I do name comma age here, and will it just work? Awesome, it works. So that is destructuring for you. I think this is similar to destructuring in JavaScript. Like you usually do destructuring in JavaScript using, say, the object notation and all that. Like you say name, and then you have something like, I think, name equal to Karpaya, whatever, right? So this then name basically then gives you console.log, gives you Karpaya basically. And you can also do nested stuff over here, I think. So yeah, I think it's a pretty interesting thing. So we're basically doing that destructuring over here too. So let's look at the hint also, and I'll remove this pattern here, whatever is Furry McPherson is 3.5 years old. Okay, right, it's a kid. Let me type hint. Take a look at data types, the tuple type section of the book. Okay. Particularly the part about destructuring, second to last example in section, you'll need to make a pattern to bind name and age to the appropriate parts of the tuple. You can do it. It was pretty straightforward, intuitive, but we're still going to check out what these people have to say. So we're talking about data types, primitive types, and all that. The tuple type, generally of grouping together a number of values with a variety of types into one compound type. I think the idea is basically, it's like, say, Karpya, and then say my age, say 20, and then like, that's not my age. Karpya 20, and like you want to put it together. You want it to have some meaning, right? Together, like it's like all related stuff together. You could put it in a tuple. In other languages, you could put it in a struct. I think Rust also has a struct. I've noticed it. So you put things together so that you can know that it's all related, right? It's like a record. So I think tuple can be considered like that. So tuples have like you're putting variety of types. You can put variety of types, or I think you can put the same type too. Like you can put integer, comma integer, and whatnot into one compound type. And tuples have a fixed length, and like once declared, they cannot grow or shrink in size. Okay, so it's like I guess with this you can clearly say that you know the size at compile time, or if it has references. Okay, I'm not sure. Anyways, I mean, even if it has references, the size of the tuple itself will be fixed. The reference could be pointing to something like say memory reference and get some memory allocated and like whatever, and point to some data in a heap. But I think this should be in a stack only, and they cannot grow or shrink in size. Looks like they are kind of like immutable and like constant. You create a tuple by writing a comma separated list of values inside parentheses. Okay. Each position in the tuple has a type. Okay. So first position, second, or like zeroth position, first position, second position. Types of different values in the tuples don't have this. They don't have to be the same. Types don't have to be the same, but they can be. We have additional optional type annotations in this example. The variable tuple binds to the entire tuple because the tuple is considered a single compound element. To get the individual value out of a tuple, we can use pattern matching to destructure a tuple. Can I get only this value though? Like only say one value and ignore the others? Like, is that possible? Like, say I do blah. There should be an error ideally. Yeah, this has type expected tuple with 3 elements, found one with 2 elements. Okay, so can I say underscore? Oops, underscore. Can I ignore that? Yep, I can. Awesome. Cool. Can I say dummy and not use it? Will it say it's not used? I think there'll be a thing like Rust, what do you say? Warning. Let's see, Rust C, Rust links, Rust C. So yeah, help. If this is intentional, prefix it with an underscore. So unused variable, right? So now, yep, it's unused, right? Instead, you can just do underscore and it will just be gone. Yep. Oops, oops, oops. Cool. So now, yeah, I can ignore things. And this program first creates a tuple and binds it to the variable tube. So it creates tuple, binds it to this variable. It then uses a pattern with let to take tube and turn it into 3 separate variables X, Y, Z. So I guess this would be useful in cases like when you have some mathematical operations, like you have some graph that is like a 2D graph X comma Y, and you want to take the X and Y, you can just do this. Or if you have X, Y, Z 3D graph, you can do that. This is called destructuring because it breaks the single tuple into 3 parts. Finally, the program prints the value of Y, which is 6.4. Okay. Oh, I didn't know you could do this. Wow. I knew you could do formatting identifier and then put comma Y and whatnot. Like you could do this, I knew that. I don't know you could do this too. What happens if I do both? Like if I do put name and also formatting specifier missing, argument never used. Ah, okay. Basically, this is taking up like a named argument. I knew that there was like 0, 1 and all that. If I put 0, it will pick up name, and then for this one, it will pick up like based on position. So again, start from 0. So this is not being used. So it's like, hey, you have to give me a formatting specifier, not identifier, it's not a formatting specifier. Apart from indexes of these 0, 1 to 3, you can also use the names, and it should just work as fine. So this is, I guess, similar to JavaScript, wherein you can do something like console.log, and then you can do things like this. Name is years old, and it's right. So this is interesting. So I could just do age here, and that would just work fine. Awesome. Cool. So this program first is you can also access a tuple element directly by using a period. Okay. Similar to array, like how you reference elements of an array, you can just do dot 0 and like dot 1 and whatnot. So interesting. So can I say cat dot? Will it help me? Can I say 100? I don't know. No, that doesn't work. So expected thing in format string. Okay. Can I just put a thing? No. So it looks like I can't do dot 100 like that over there alone. Or dot one, I think there. I can do cat. Does it say? Was by the way, it's actually okay. It's like a cat. I keep thinking of cat like the concatenation cat thing. But this is not some baby. It's a cat and like baby cat, kitten. So it does not implement this. Okay, so it has to implement a display so that it can be displayed as a string. So cannot be formatted with the default formatter with that rate in format. You may be able to use question mark, colon, question mark, colon, hash, question mark, for pretty print instead, for pretty print instead this. Okay, cool. We have 0277. You might have seen this before. Let's check it out. Cat, interesting. You try to use array which does not implement some trait in a place which expected that trait. So this thing expects that trait, but it's not implementing that trait. And can I say blah and then be like let blah equal to cat dot 0? Now you can see 0, 1, 2. Right? What if you say 100? Interesting. 100. 100 doesn't know feel 100 on type. 10. Can I say name? But it won't work, right? Because when I define the tuple, there is only positions, like there's only values. There's no named values. There's no name for this. There's no name for this. There's only position 0, 1, 2. Right? No field. Okay. And then 2. Cool. Interesting. This is blah for some reason. Oh, that's because 2 is this. Okay, blue. The variable's name, the value, everything was blah. That should be blue. Yeah. Cool. So I can do that. This program creates and then access each element of the tuple using their specific indices. As it must say the first index in a tuple is 0. The tuple without any values has special name unit. This value and its corresponding type are both written as like empty tuple and represented an empty value or an empty return type. Okay. Expressions implicitly return the unit value if they don't return any value. Right. So this is what we noticed before when we got errors like, hey, it's returning empty tuple, like, or it's returning nothing when it was expected to return something, right? So that's the tuple type. The others are different, like array types and whatnot. So with that, I'm going to go ahead and like stop the recording and I'll see you in the next one. Bye-bye.